Hey everyone, it's Ken. We've seen the definition of the definite integral. It's a limit of Riemann sums. More intuitively, it's the signed area under a curve or above the curve if the curve is negative. And in this video, we want to head towards being able to actually calculate the definite integral for different functions. And in service of that, I want to go over some of the properties that the definite integral has. And first of all, I want to help you calculate maybe the simplest definite integral. So say we want to take the integral of a constant, maybe just y equals constant. And I'm Ken, so I'll use constant k. And we're going to integrate from a to b, just like constant, dx. And I can do this from the definition of the integral, or I can just use my geometric understanding of area under the curve. If I use my understanding of area under the curve, then here's what I get. So I've got a constant function at height k, and I'm starting at a and ending at b. And so the area under the curve and above the x-axis is just going to be the height times the base. So k times b minus a. What if I want to calculate that straight from the definition of the integral? I can certainly do that. And let's see. So the way I'd like to calculate this, I could use left endpoints, right endpoints, midpoints. Doesn't make a difference. I'll use right endpoints. I'll take the limit, n goes to infinity, of the right-hand approximation, which itself is going to be the sum from I goes from 1 to n. And I plug in f of xi times delta x. And remember that delta x here is b minus a over n. And so I have to calculate that out. So my f of x, that's just equal to constant k. No matter what those xi's are equal to, when I plug them in, it's just going to give me that constant value. So when I continue on, I'm going to end up with the sum of k times b minus a over n. So it's getting closer to what the actual answer is going to be. Now, when I take this sum using summation notation, what I'm doing is I have n terms. I goes from 1 to n. And here's a formula that I have to plug I into that tells me what I'm adding together. But this formula doesn't depend on I, it's just a constant. So what this sum is telling me is to just add this number together n times. And so if you add a number together n times, isn't that the same thing as multiplying it by n? You'll see those n's cancel out. And you'll just be looking at the limit as n goes to infinity of k times b minus a. And since k times b minus a, it's constant, doesn't depend on n. It's going to stay constant no matter what n is doing. So the answer is just going to be k times b minus a. So on the one hand, I showed you that the integral had to be k times b minus a using my geometric intuition. On the other hand, I was able to show it with what you might call a formal proof using the definition of the definite integral.